Vector analysis. Part 3. We're looking at vector products. Vector product is also called cross product. An example is when you have A cross means times, A cross B, and that's equal to modulus of A times modulus of B, sine of the angle between them, times the direction vector here, unit direction vector. So that is this means it's normal to A and it's normal to B. So N indicating it's normal. Normal means perpendicular to A and perpendicular to B. And so this is in a direction perpendicular to A and B, so that A and B, AB and A cross B form a right-handed set. So this normal here is A cross B vector, and that is indicating it's perpendicular to A and perpendicular to vector B, where theta is the angle between A and B. So this is the angle between A and B. So you can have this in two form, where it's even like if you're turning a screw in the right hand screw. So we have A cross B equals modulus of A times modulus of B, sine of the angle between A and B, times the normal vector. This is a right-handed screw, and you can have it in the opposite direction where it's left-handed. This is coming in the left, where A cross B is B modulus of B times modulus of A, sine theta n normal. The hat on top of n indicates it's a vector, and this can be written as minus modulus of A modulus of B sine theta n normal. This is indicating that if you do A cross B, it can also be written in terms of B cross A, but it will be negative because this vector is not commutative. If it's commutative, it won't be negative. It will be the same value. But when we did the dot product, A dot B is equal to B dot A. But in case of the vector, A cross B is not equal to B cross A, but it's equal to minus B cross A. So therefore, scalar product is commutative, but vector product is not commutative. The order of times multiplication matters. Let's look at some properties here when we're looking at this vector product. So here are the vector J and I, which we called unit vector. So if we go back here, so that will be a unit vector there, unit vector there, unit vector. So this unit vector means the vector, unit vector means that is 1, 1, and 1, hence the word unit. So they are right angle to each other in this case. And so what we did was, and that's the normal here, so that's the vector here. And if that's the case, let's look at vectors that are parallel to each other. So if I times I, because I will be parallel to I, which means the angle between the i's, the two vector I, will be 0 if they're parallel. So I times I would be using that formula. So that would be, let's say that vector is I, and that's I cross I will be the modulus of 1, which is 1, cross modulus of modulus of 1, which is 1, times sine of the angle between the two I, which is 0, times the vector n. So that will be 0 because sine of 0 is 0. So that will be 0. So I cross I is 0. J cross J will also be 0 because it's a parallel. K cross K will be 0. But what about if they're perpendicular to each other? Like this is perpendicular to that is perpendicular to that. So in that case, I cross J are perpendicular to each other. Remember, I is 1, J is 1, and that will be equal to 1 times 1 times sine of 90 degrees, because we're using that formula, where n vector here is the k. You can see that's the k there. So that would be sine 90k. That equals to 1 times k, which is k. So I cross j gives k. J cross k will give you I, and k cross I will give you j. And the way to remember is to use a circular connection here. So you start with I because I is your x, j is your y, and k is your z. You only start with x, y, z. So in terms of increasing alphabet, x, y, z. So if you do x cross j, you get k. So x cross j, you get k. So you have to be in this direction, obviously. And then if you then do j cross k, you get I. So j cross k is I, and k cross I, you get j. So k cross I, you get j. But if we do the reverse, if we do I cross k, you're going to get minus j because you're going in reverse. I cross k is minus j. K cross j is minus I. Let's say j cross I, you're going to get minus k. So that's what happened. Because you've done in reverse, you get negative. If you do k cross j rather than j cross k, you can get minus I. If it's j cross k, you get I. So it's important that because the order is very important here, because we're using cross product, not dot product. So in this case, I cross k is minus j because k cross I is j. So this side is the positive value that you get. So I cross j is k, j cross k is I, and k cross I is j. But if you go in reverse, j cross I, which is that one here, j cross I, you're going to get minus k. I cross k, that one, I cross k, you're going to get minus j. And k cross j, you're going to get minus I. So that's the properties that you need to watch out for when we're looking at these vectors. It takes time to sink in, but once it's understand that, then you can always remember that. Also, the other property that we need to use to be able to find the A cross B. So A cross B, we're using this determinant rule where we have I, j, k, and vector A has its coefficients here, and vector B has its coefficient here, and we assign positive to I, negative to j, and positive to. So what are we using here is determinant. So if I write that down as determinant, so we're using determinant method. So that's what this is. This is determinant. So we put the in the matrix form. So now, and then what we do is we, for I, so for I, we is positive. So we say A cross B equals positive because that's a positive, right? And then what we do is we're going to draw a line here and we draw a line there. So when we draw a line, so I can do that now. So I can draw a line here like that. So what I do is I'm going to draw a line here, right? And I draw a line there. So which means I'm working on I. So that's why I've got I here on the point here. So that's what I'm working on now. So what's left that I haven't covered is BZ times AY, you see BZ times AY minus BY times AZ. So that's what we're going to do. We do BZ times AY. You always start from the right here and diagonally. So BZ times AY minus, or you can say BZ times AY equals BY times AZ. But we need to put it into, we need to put it into 0 to make it 0. So it's going to be BZ times AY minus BY times AZ. So that's what this is, and then that's I. But this is for J now, J is minus, so we put minus in front there, because J is minus, so we put minus there, and then open bracket. Now we're going to draw a line here, so let me just take that off, and then we now need to draw a line here for what we're doing now. So I'm doing J, so I'm drawing that line there, so we're doing that one. So in this case now, we have what's left that we haven't covered is we've got now again diagonally, so you have to do that diagonal and diagonal. So BZ times AX, BZ times AX minus, it's always minus BX times AZ. So minus BX times AZ, and then that's for J. And the final one we need to do is the K. You see, we need to do the K, so we select the K like that, and we draw a line again. So now we're doing K at this point. So again, K is plus. You can see that's plus there, so we'll put the plus there, open bracket. And now what we got left that we haven't covered, we haven't drawn a line on, is BY times AX. So that's BY times AX minus, it's always minus, because you got 2 by 2 matrix here. So you do minus BX times AY, and that's for K. So this is what we now call the vector product. Is not commutative, but it is distributive over vector addition. So if you do A cross open bracket B plus C close bracket, it will be equal to A cross B plus A cross C. So that's allowed. Well, the best thing to do now is to do an example. So if we do an example, see what we get. So here's a question that says, an example, it says find the sine and the angle between the two vectors A, which is that vector, and B, that vector. So first thing is they're asking for the sine, and obviously that gives us the clue that obviously we're using vector product or cross product here, and then we can also find the angle. So the best thing to do is to first of all write down the equation for that vector. So A cross B, we know that is going to be A modulus B modulus sine 90 degrees and N vector. All right, and so ultimately we want to rearrange this equation to be able to find sine of that angle. In order to do that, we need to find the modulus of AB. So we need to find the modulus of cross B. Once we get A cross B, we want to find its modulus. Then we need to rearrange this equation. But at the same time, the modulus of N, which is going to be 1, because it's a unit vector there. And so now what we need to do is rearrange this and write sine theta will be equal to the modulus of cross AB, A cross B, sorry, divided by the modulus of A and modulus of B. So that's what we need to do. And then to find the actual angle, we can then say theta will be sine to the power minus 1, right? Modulus of A cross B over modulus of A and modulus of B. So that's it. That's what we need to do. And to do that, we need also to first of all be able to find A cross B. So that's where the challenge is. That's the more difficult one that we should be able to do. And that can be written as, like we said, I, J, K. We need to write the vector down as 3. So that's A there. So I'm looking at vector A, 3 minus 2, 4. And I'm looking at vector B now, which is 2 minus 3 minus 2. So that is the vector there. And it might be best to remind myself that that's plus, that's minus, that's plus. And that will be equal to, so let's put it that way, equal to there. Now we can say, right, so I'm going to write them quite small, so to fit in. So that will be for I, I'm going to put a plus there. I'll use a square bracket to make it easier. Right, so what I'm going to do now is draw an arrow down there so that you can see what I'm doing. And I'm looking for that one. So now you can see I'm looking at the 2 by 2 matrix there, which is minus 2 times minus 2, that's 4, right? Minus, then I've got minus 3, so I've got minus 3 times 4. So minus 2 times minus 2 is 4. And I go minus 3, so that's minus 3 times 4. Because you always minus when you do the diagonally. So that times that, minus that times that. That's what you have to do. So that would be minus 12 there. So to be honest, I'm going to put that back in the square bracket and stick my I there because I've just done the I version there. I've just done the I. So that's what we're going to be doing for J and K as well. So for K, right, I'm going to now draw my line for K. So I'm just going to draw a line there because I'm doing K now. So I'm doing J, sorry. So J, but J is minus. So I'm going to stick minus in there because that's minus for J. And I'm doing the vectors now for, because I've drawn the blue line now. So I'm going to do minus 2 times 3 minus 2 times 4. So it might be better to use a square bracket there. So I'm going to do minus 2 times 3 is minus 6. And then minus 2 times 4 is 8. So put that in close bracket, I'm going to call that J. Right. And the final one I need to do will be the K here. So I can see if I'm doing K. So K is positive, so I could just draw my line there. Alright, so I'm doing K now, K is positive. So I'm doing the yellow one now. So I have to stick my positive there, square bracket. And now I'm going to do minus 3 times 3, that's minus 9, minus 2 times minus 2, so that's minus 4. So now what I need to do is minus 3 times 3 is minus 9, minus 2 times minus 2, that's minus 4. Close bracket, square bracket, and I stick K there. And that's it. And that's what we need to do. And now I can finalize what I've just done to be equal to minus is plus. So now it'll be 16I. Alright. Now I've got minus 6 and minus 8. That's minus 14. Minus 14 times minus 1. That's plus 14. So that's plus 14J. And I've got minus 9. And I got minus 4 minus 4. That's plus 5. Plus 4, sorry. Minus 9 is minus 5K. So now I've arrived at what A cross B is. So A cross B is equal to 16I plus 14J minus 5K. So A cross B equals 16I plus 14J minus 5K. So what I need to do now is to find the modulus of A cross B. So modulus here, if I just write it here, then A cross B modulus will be square root 16 squared plus 14 squared plus minus 5 squared, and that will be root, square root, well, 16 squared plus 14 squared minus 5 squared, so that will be 256 plus, so 14 squared will be 196, and plus minus 5 squared is plus 25. So you got 25, and then you're going to add plus 256, and that together gives you square root of 477. And a square root of 477 can actually be simplified to 3 root 53. So that's the modulus of AB. Now what we need to find is modulus of A. So let's do that in different color. So modulus of A will be equal to, so we know what A is. A is 3 minus 2, 4. So it's going to be square root, that's 3 squared, plus minus 2 squared, plus 4 squared, and that will be equal to square root of 9 plus 4 plus 16, and that equals to square root of 29. Now for modulus of B, we know that is, mod B is 2, so that'll be 2 squared plus minus 3, that's minus 3 squared, and minus 2, so plus minus 2 squared. And that will be equal to square root of, well, we got 4 plus 9 plus 4, so that will be equal to square root of 17. So now we found the modulus of A and B. So to find the sine, so sine of theta will be the modulus of A cross B over modulus of A and modulus of B. And we know what they are. So that will be 3 root 53 over root 29 times 17. And that will be, so if I plug that into calculator, so that's, so theta will be sine to power minus 1 of 0.9836 363, just write the whole number there, 8978. And what would that sign be? So if I do the shift sign, and then, so that actually gives 70.6 degrees. So we have found the sine of the angle between the vector A and B using a cross product or dot or vector product, and that is the sine of the angle between them. That's the sine of the angle, and the actual angle theta is, so that's theta there, theta is 79.6 degrees, roughly about 80 degrees. But the 79.6 that you see here is actually 79.621. So if I write the 79 as, so if I say that would be 79 degrees, and the next is minute, and you know it's got minutes and seconds. So what I need to then do is divide or multiply the 0.621. So if I take away 79 from the answer, I get 0.6214482665. If I times that by 60, that would give me minutes. So that would be 79 point, in this case, 79 degrees, 37 minutes. And if I take if I take away 37 from the answer now, so minus 37, because I get 37.2868959. If I take away 37 from there, that'll be minus 37. I get the 0.0286 for the minute, so 0.2866. 0.2868959897 minutes. And if I times that by another 60, I'll get it seconds. So that will be 17 seconds. So, well, that's how you write it in degrees, minutes, and seconds.